Good morning, everyone. My name is Michael Balchanos. I'm a research engineer with the Aerospace Systems Design Lab, School of Aerospace. And the topic for today is actually presentation number 14, is on a model-based approach for a mobility and traffic incident forecasting environment. So some context on how someone from the School of Aerospace got invested on looking into traffic-related topics and traffic simulation. So we're part of a larger initiative, the Smart Campus Initiative, which we have been working with the Georgia Tech facilities and the Georgia Tech administration since 2013. And part of that effort, and some of my colleagues, Dr. Duncan and Dr. Liu, have spoken about it in the previous presentations, a big part of that was to envision a digital twin of the campus as part of the enabling solution. So after looking to the energy side of the campus with looking for opportunities for efficiencies, we started diversifying and looking into other aspects of the campus like safety and mobility and how planning could potentially be taking those aspects into account for the purpose of creating a more sustainable campus for the future. So we started looking into some of the data regarding safety, mostly on the traffic side, with a partnership with Georgia Tech Police and their kind support. And then we, as we had further discussions with them, we started learning more about what are the most pressing incidents on campus. And one of them actually is pedestrian safety. Three main reasons for why that topic is a big priority. One of them is the fact that the campus is growing in terms of population. So you have a rise on the population because every year we admit more students. But at the same time, the physical footprint of the campus stays the same, or it doesn't grow as fast as the population. The second big factor here is the fact that you have alternative mobility devices. You have those scooters, you have different types of electrified skateboards. So that landscape starts changing, and obviously there are some higher risks in terms of how traffic incidents can happen and could potentially hurt pedestrians. And the third one is the fact, and I think we're all in the same boat on that, the fact that there is a lot of distracted behavior while we're walking around campus. We check our cell phones, we use headphones as we walk and so forth. So that's pretty much the motivation, and they came to us and asked us what can we do about those issues and how can we use some of the techniques that we have been using in a wider sense on the Smart Campus for being able to benchmark how is the pedestrian safety landscape on campus right now and how would that change in 5 or 10 years. So our approach was a main three-step approach. So benchmarking the campus in terms of pedestrian safety on how things look right now, then user modeling and simulation capability to be able to model traffic and also furthermore be able to predict the counts of incidents that could happen in a changing landscape with regarding traffic. And then, of course, provide a solution that they could be running some what-if hypotheticals and use cases so that they can plan accordingly. So we used some data. A big part of that task involved actually identifying the data sets that were available. So we got access to the safety database, which we learned more about what types of pedestrian incidents occur and where they occur, when they occur, so we were able to find those trends. Also, there were some data from the GDOT regarding the traffic levels on campus and also the Google Maps. Obviously, that data is not open to everyone, but we were able to kind of reverse engineer some of those trends and compare them to some other data that we had. And also in terms of the population activity, which is also a big part of how you can model the traffic, not just for the vehicles, but the pedestrians. There was data available regarding registration and how those registration volumes linked to which buildings where those classes are happening. So with some basic steps, we were able to create a first rudimentary model on how people are moving around campus. So in the end, that gave birth to a complete landscape of traffic simulation or traffic modeling for the campus, which included both the vehicle level and the pedestrian. So those were essentially the basic ingredients, and to some extent that's a data fusion problem because you have to rely on data, you have to rely on some hypotheses and some assumptions, and then there's also the integration aspect where you have to put them all together in a capability, modeling and simulation capability that allows you to parametrically change conditions and create different use cases. So we used agent-based simulation as the underlying approach to actually capture both layers, the pedestrians and the vehicles. And in the end, we were able to produce a map of the campus where eventually, based on some conditions like the hour of the day or the type of the weather, we're able to see what are the likelihoods in terms of incidents happening and in which parts of the campus. Then we also had the data that we got from GDPD as part of benchmarking our results and comparing them to how reality looks like that. The main answer that they were looking from that exercise, at least from the GDPD side, was we know where the hotspots in terms of the high likelihood of incidents are today, but what's going to be the next big hotspot in 2 or 3 years from now, or maybe there's going to be more than 1 or 2 hotspots. So we're able to identify some locations based on how campus is growing, where new buildings are coming in, and what implications that's going to have into traffic for pedestrians and vehicles. The end result was interesting. Essentially, we looked into 2 use cases as part of that exercise. One was what happens when you have a big event on campus where you can't really close campus like a football game and you have full control of traffic. What happens if people still have to come to work and operations need to happen as usual? And the other one is what's going to happen in 5 years from now when we're going to have new buildings, we're going to have the landscape of the campus be changed, new corridors and so forth, or maybe even new technologies, which is something aspirational for us in the future. What's going to happen when we have more autonomous vehicles or connected vehicle technologies and so forth. So this is what I had for today. I hope that topic sounds interesting to most of you guys, and definitely we're looking forward to collaborating with you more as part of the sustainability initiative. Thank you.